Assalamualaikum warahmatullahi wabarakatuh. Greetings everyone. I am Muhammad Hakim HAYROMAN, currently in my 8th semester. Today I am going to present my progress for my research. I am excited to share the advancements in my research with you today. The title of my presentation is Open Circuit Fault Tolerant Boost Rectifier based on Single Phase Matrix Converter. In the context of my project, I have identified and focused on two key objectives. First is to propose a new AC-DC converter topology based on SPMC that can reroute the current flow to other switches if one or more switches in the converter are open-circuited. This implies that the current will seek an alternative path to circumvent an open-circuit fault. In the depicted image, we observe the optimal circuit configuration of the SPMT with rectification operation. It undergoes charge and discharge cycles for both positive and negative phases. The project primarily revolves around four key switch groups, which is S1, S2, S3, and S4. Each switch group comprises two IGBTs or switching devices with common emitter connections. The switches labeled B, which is S1B, S2B, S3B, and S4B, remain in a constant on state, serving as the fixed variables in the setup. Conversely, switches labeled A will alternate between on and off in a predefined sequence according to the specified current option route condition. In our presentation today, we will discussing a reroute strategy known as current option route or COR. Within the COR framework, we have identified four conditions, each designed with the assumption that at least two switches in a circuit are in the off position. In the context of COR1 conditions, consider the scenario where both switch 1 and switch 2 are turned off. In every condition of operation, in every current uh, in every COR, there are four scenarios concerning the flow of current. This arises from the current's path being engaged in both charging and discharging modes during both positive and negative cycles, resulting in four distinct circuit situations. To illustrate, the initial two circuits pertain to the positive cycle state, the left one functioning in charge mode, while the right one operates in discharge mode. The same principle applies to the two circuits below, but in the context of negative cycle position. For condition COR, switch 3 and switch 4 is turned off. For condition COR4, switch 2 and 4 is turned off. So all these four conditions is function as to refer the situation and the alternative path taken by the current. Fault tolerant. Fault tolerant is referred to objective number 1, which able to reroute the current flow to other switches if one or more switches in the converter are open-circuited. This is the outcome from hardware experiment illustrating the transition from COR1 to COR2. In the uppermost section, we have signals S1A, S2A, S3A, and S4A. The bottom two represents the output voltage and current input. Based on the results, in the event of a fault occurrence, the input current will equal to 0 and the output voltage will drop. This is the point at which the transition take over and provide backup for the faulty situation, allowing uninterrupted power supply to persist. Same goes to the other transition. This is COR2 to COR3. This is COR3 to COR4. This is COR4 to COR1. Next is objective number 2, which is continuous from first objective. To develop a new open circuit fault detection technique for the proposed converter topology that will detect the faulty switch's location of the open circuit fault of a switch. Fault identification. The primary focus of our second objective is to directly identify open circuit faults occurring in the circuit, specifically targeting the faulty switches. As illustrated in this flowchart, we can observe how the identification of faulty switches takes place. This is a flowchart for condition COR1. How does the system identify the conditions, such as COR1, which focus on the open circuit fault on switches 1 and 2? To begin with, it is essential to verify that the voltage output is at level of 50 volts. This is because the circuit is boost rectifier, so we must make sure the voltage output is higher than the input. Moving on, the next step involves examining whether the cycle is positive or negative. This is aimed uh, to ensure that the observer can discern whether the current flow is in the opposite direction or not. The next step involves examining the current flowing through the inductor. In the event that the current in the inductor at the switch is zero, it indicates that the switch are at fault. So in this flowchart illustration, when the negative cycle of inductor current reach zero, switch S4 is deemed to be in a faulty state. If the positive cycles of inductor current is zero, it indicates a malfunction in switch S3A. The method is same for COR2, 3, and 4. This is the result when S4A is in faulty condition. This is a flowchart for COR2. The result when S1A is in fault condition. Result as when S2A is in fault condition in COR2. This is flowchart for COR3. The result when S4A in COR3 in fault condition. The result when S2A in fault condition in COR3. This is a flowchart for COR4. The result when S1A is in fault condition in COR4. The result when S3A is in fault condition in COR4. So, in conclusion, the accomplishment of both goals has been effectively executed. Fault tolerant is a method that ensures the uninterrupted provision of power even in the presence of faults. The ability of the current to reroute to another safe route is a big advantage to avoid permanent fault state. So, preventing the occurrence of a permanent fault state and allowing for the continuous flow of current. Fault identification Fault identification is a method which capable of pinpointing the location of a faulty switch. The ability of fault identification technique is able to precisely detect faulty switch by through the analysis of voltage magnitude and input current observations. So for my status, currently I have completed the hardware experiment finalized my thesis and submitted the intention to submit thesis form. Additionally, I have submitted my thesis to faculty and waited to be viva. Moreover, I am pleased to announce that the journal submission has received successful acceptance from IJPADS and the conference paper has been approved in IEA Con. That's all from me. Thank you.